now. Last class we did quadrilateral characteristics and pictures, finding angles and sides. Today we're going to involve some algebra in that, so you still need to know what your properties of a parallelogram are. So for instance, in a parallelogram, opposite sides are congruent. Well, congruent means we're going to set them equal. So I'm going to do 9x minus 25 equals 5x plus 7, because opposite sides are congruent. Solve for x, it says. So subtract 5 to one side, you get 4x, plus 25 to the other side, you get 32, and then we would divide and get x equals 8. That's all it said, solve for x. This next one, sometimes they give you information in writing instead of putting it in the picture. So on this one, we have ns is 2x plus 7. SQ is 5x minus 23. So again, this whole example is called parallelograms. So in a parallelogram, diagonals are bisected. And I'll say bisect each other. Since the diagonals bisect each other, I know those two parts of that diagonal are equal. So subtract either way. You want to get the x's on one side and the numbers on the other side. Subtract that way, I get negative 30. So I found x to equal 10. Well, let's make sure. This one says find NQ. So NQ is the entire diagonal. So we need to plug this into at least one of them, or both of them, to get the whole length. So if you do just NS, 2 times 10 plus 7 is 27. But this one wants NQ. So NQ would have to be doubled because it's the entire length. So NQ would equal 54. So I want to see your work. Just solve for x, and then I want to see what you get for that whatever segment it's asking for, or angle. Okay, so the next one, angle KLH, it says is 134. So KLH, this whole angle in this corner is 134. Alright, so we got to figure out how is that going to help me find x. Well, in a parallelogram, the angles aren't bisected, so this isn't 25 and 25. But we do know these lines are parallel. And if lines are parallel, we can use what's called alternate interior angles to help us out here. Again, multiple ways to do this. Let's say if this is 25, this angle right here is 25, because those would be alternate interior angles. A little bigger there. So, in a parallelogram, consecutive angles are supplementary. And I'm just going to say equal 180, because that's the same as supplementary. So I'm going to say 4x plus 9 plus 25 plus 134 equals 180 degrees. And I would combine any like terms, so I would combine the 9, the 25, and the 134. So I get 168. Now we'll solve the x by itself, subtract the 168 to the other side. Gives me 12, so divide, x equals 3. And this one just says solve for x, so I know I'm done. So you're going to use your properties or characteristics of quadrilaterals to set up equations now to solve. Alright, let's look at the next one. This one, example 2, everything in example 2 is related to rectangles. Okay, so we're looking at our rectangle properties, like 4 right angles, opposite sides are congruent, diagonals bisect each other, the diagonals are congruent, all types of rectangle properties. So, and US is 2x plus 10. Since we know diagonals are congruent, that means that I can set RT equal to US. And solve for x. We do have to solve for x to find BT. Subtract and add the 14 over. Alright, so what they're wanting us to find is VT, just from here to here. Okay, so let's figure out what a whole diagonal is. So like RT. That gives me 40 minus 14 equals 26. So RT is 26, so VT is only half of that. So VT would equal 13. Okay, diagonals are congruent, and diagonals bisect each other. So these are all four congruent in that picture. So all those little segments would be 13. Alright, so this one's another rectangle, kind of vertically here. JM is x plus 17, and MK is 5x minus 23. Well, we learned on the last one that the diagonals are congruent and the diagonals bisect each other, so I put in that picture that all four in a rectangle, all four of these are congruent. So we can just set 5x minus 23 equal to x plus 17. And solve for x. Subtract x to the other side. Add 23 over. And divide by 4. X equals 10. Find JL. So JL is an entire diagonal, so let's find JM. So 10 plus 17 is 27. Okay, so JL, you would just have to double that to get the whole length is 54. Okay, so both of those were related to the diagonals. The next one's not related to diagonals, it's related to angles. So you got to remember, what do we know about angles in a rectangle? All the corners are 90 degrees. So there's a couple different ways you can do this one. One, you could put a box in this corner and know these three angles add up to 180 because that makes like a right triangle. If you cover up that half of the picture, that would be a right triangle. Another way to know, using alternate interior angles, that would make this angle up here equal to that angle up here. So this angle could be x plus 20. And these two angles together add up to 90 degrees. So lots of different choices. You could say x and y are supplementary. You could put the 5x minus 8 down here. Several different options. So I just said if this is alternate interior, these two have to add up to 90. And I'm solving by combining like my terms, subtracting the 12 to the other side, and then dividing. At x equals 13. So let's see. Find the measure of angle XZY. So let's look in this picture. XZY is this angle down here. So I'm going to plug it into that. 13 plus 20. Measure of angle XZ. Oh, I did XZY. It asked for XZW. Scratch that. That's XZY. We want the measure of angle XZW. So that's this side over here. So that would be the same as 5 times 13 minus 8, because it's alternate interior with that side. Okay, my bad, don't do that one. Do this one. No, that is 57 degrees. I guess if we had plugged it in here and got that was 33, we could have taken 33 from 90 minus 33, and still got my 57. So just a couple different ways to do that. If you read the letters right, it was XCW, so I needed this angle here, and I accidentally put it in that angle. So if you found that angle was 33, you could always just take 90 minus 33, and that could also get you the 57. So multiple correct